Expected value. The expected value of a random variable x is equal to the mean, which is the population mean. Now, we can therefore find the expected value by computing the sum of x times the probability of x, just as we do for finding the value of the population mean. So let's take a look at example 6. Be a better bettor. You have $5 to place on a bet in the Golden Nugget Casino in Las Vegas. You have narrowed your choice to one of two bets. Roulette, bet on the number 7 in roulette, and craps, bet on the pass line in the dice game of craps. Now, in part A, it says if you bet $5 on the number 7 in roulette, the probability of losing $5 is 37 divided by 38, and the probability of making a net gain of $175 is 1 out of 38. Now, the prize is $180, including your $5 bet, so the net gain is $175. Find your expected value if you bet $5 on the number 7 in roulette. Now, the probabilities and payoffs for betting $5 on the number 7 in roulette are summarized in the table. So we want to create this table. So the table is going to be the following. We have the event, we have the value for x, we have the probability of x, and then we're going to take the data value x and multiply it by the probability. Now the first event is that you lose. Now if you lose, that means you're going to lose $5 because that's how much you bet on it. And the probability of losing, which is up here, is 37 over 38. So now what we're going to do is, again, we have $5 that you bet. If we lose, it's minus $5. And then we can see that the probability of losing the $5 is 37 over 38. So what we're going to do now is we're going to go ahead and multiply that. Okay, so we're going to take that negative 5, and then we're going to multiply it by that 37 over 38, which gives us negative 4.868421. Since we're in the middle of a calculation, we do not want to round this yet. Okay. Now, the next event is winning, the net gain. Well, what's the net gain if you win? Well, if you win, the net gain is what amount? Well, that amount is 175. So if you win, that means you get 175. And what is the probability of winning? Well, the probability of winning is 1 over 38. So now what we're going to do is we're going to take that 175 and then we're going to multiply it by the probability of winning, and then we get 4.605263. You can see here I rounded to 6 decimal places, and that's the best thing that you can do there so that you don't mess up your calculations. Now we want to find the total. So if we want to find the total, okay, we're going to take these two values. We're going to take negative 4.868421, and then we're going to add 4.60523, and we get a value of negative 0.263158. Now we're going to round that to the nearest cent. So we can either say that it's negative 0.26 or negative 26 cents. Okay, so it also shows that the expected value in this case is going to be negative 26 cents. And that is, for every $5 bet on the number 7, you can expect to lose on average of 26 cents. Okay, now let's take a look at the next question, part B. It says, now if you bet $5 on the pass line in the dice game of craps, the probability of losing $5 is 251 over 495, and the probability of making a net gain of $5 is $244 and 244 over 495. Now, if you bet $5 on the pass line and win, you are given $10 that includes your bet. So the net gain is $5. Find your expected value if you bet $5 on the pass line. Now, the probabilities and payoffs for betting $5 on the pass line is going to be summarized in the table. So just like we did in the previous example, we're going to do the following. Again, we have our event, we have our column for the X, we have our probability, and then we're going to take our data value X and multiply it by our probability. Now, the first event is lose. So what do you lose? Well, the data value, if you lose, is going to be -5. So if you lose $5, that's going to be the data value. Now, what is the probability of losing? Well, we know that the probability is 251 over 495. So now we're going to take X and multiply it by the probability. So we're going to take our -$5 and multiply it by 251 over 495, and we end up getting -2.535353. Now let's take a look at the next event. The next event is winning. So what is the net gain if you win? Well, they told us that the net gain is going to be $5, so we know it's going to be $5. And what is the probability of that net gain? Well, that probability of that net gain is 244 over 495. So we have 244 over 495. So now let's go ahead and calculate. So we take that $5, multiply it by that 244 over 495, and we get 2.464646. Now we want to find the total of this column. So to find the total of this column, what we're going to do now is then add these results. So we get -2.535353, and then we're going to add $2.464646, which gives us a value of -0.070707, which, rounding it to the nearest cent, tells us that we have -0.07 cents, or just -7 cents. So it also shows that the expected value in this case is -7 cents. That is, for every $5 bet on the pass line, you can expect to lose on average 7 cents. So here is the interpretation. The $5 bet in the roulette resulted in an expected value of -26 cents. And the $5 bet in craps resulted in an expected value of -7 cents. Because you are better off losing 7 cents instead of losing 26 cents, the craps game is better in the long run, even though the roulette game provides an opportunity for a larger payoff when playing the game once.